Hello everyone, welcome to my channel. In this video, we are going to understand very basic concept in computer networking, which is very much required to understand core concept of computer networking like IP addresses, subnet, protocols, switching, routing, etc. The agenda for this video is that we are going to understand transmission media, transmission modes, and history of topology in computer networking. So what is transmission media in computer networking? It is a path for connection to travel in network. For example, we have two devices and they would like to share some data between each other. So how many paths they have? Either they can share the data by air or they can share the data through physical connectivity. So it is wireless, it is through wired. So we have two parts, right? So networking media is divided into two parts, wireless and wired. Most of the connection nowadays are wirelessly or with copper wire connectivity. So in wired, we have four types of cables. The first one is unshielded twisted cable. Then we have shielded twisted cable, then coaxial cable and fiber optics. Before understanding the wired one, I would like to discuss on wireless first. So in wireless, how the data is transferred. So we use radio waves to transmit information or data between devices like router and any devices. It's an example. So main thing to understand here is we use radio waves or waves to transmit data. Coming to the wired one, we have four options. So first we are going to discuss about unshielded twisted cable. As you can see the first picture here, it is we have paired cables there for pattern recognition. It is made up of series of 8 insulated wire which is color coded. Each pair is color coded and it is very much common. For example, Ethernet cable like Cat 5, Cat 6, etc. These are Cisco cables. So the connector which we use in unshielded twisted cable and shielded twisted cable is RJ45. Okay, so let's understand one more time the UTP, which is most common type of connectivity in Ethernet network. It is unshielded twisted pair cable made up of series of 8 insulated wire arranged in pair, and each pair is color coded because at the end to end, if data is going for recognition, means if some data is, if let's say you are a network support guy and who is installing this wire, you can easily recognize the pattern in which you have the connectivity between both of the ends. And the connector which we use in this type of cable is RJ45. Then comes we have your coaxial cable. In coaxial cable, where do we use coaxial cable? We use coaxial cable in TV connections. And how it is made up. So we'll understand. So let's understand the coaxial cable. In coaxial cable, we have metal shielded by lots of insulators, and it is partially immune to EMI, electromagnetic interference. This cable is very less immune to EMI. This one is little bit immune to EMI. What is immune to EMI here? Immune to EMI is like if any electromagnetic radiation is nearby this wire, will the data affected or not? Any latency it will show or not, any data is missing or not, it will happen. So these are the ratings according to the electromagnetic interference. Then we'll understand the most commonly used for fast speed, high data speed fiber optics cable. So this is based off light. Okay. So it this is the most expensive and most reliable and fully immune to EMI, electromagnetic interference. So we use fiber optics cable for high data speeds, and it looks like this. We have cladding here, we have loose buffer here, and we have outer jacket. And nowadays we have so many types of fiber optics cable. We have lots of connector like SC, SFP, etc. for fiber cable. And for coaxial cable, we say BNC type of connectors. In fiber optics, we uses glass and plastic to cover long distance to transmit data on higher speed. Okay, so this is all about your cables. So we have two types of paths to follow, either by wireless, which use waves, radio waves. Then we have wired. Wired is divided into four parts. So this is about transmission media, how transmission media happen in computer networking. I hope it is clear. If you have any doubt, you can ask me in a comment section. Second, we have the concept of transmission modes. So it is a process to define the way of transmission, and there's two ways to transfer the data. Either we can either we can transmit the data simplex, that means only we can send the data. For example, we have our monitor connected with mouse, keyboard. So what are they doing? They're just sending the data. So this type of mode is called simplex mode. Coming to duplex, we have two types of duplex mode. Either it is half duplex, either it is full duplex. In half duplex, at a time, data either receives or sends. For example, walkie-talkie. Either you can speak and or you can listen. But the most common type of transmission mode is full duplex. Another example for half duplex is old version of Bluetooth, where you can just simply do half duplex transmission mode. Here you can receive the data you can send the data at a one time. Okay, so both devices can send and receive data at a time. This is full duplex. The example is nowadays Bluetooth based out apps like Share It, Mi Share, etc. Now let's move to our third topic, which is history of topology. So first, let's understand our what is a topology in networking. So the arrangement of network that comprises node or connecting lines via sender and receiver is called your network topology. First thing we are going to discuss is the first topology which we had is called bus topology. In bus topology, it is based out of a backbone wire, means this wire. If that wire goes down, the connectivity to the whole topology goes down. It is a network type in which every computer and network device is connected to a single cable. It requires lots of cabling. Security is not at all exist. So we come up with the next topology. So the next technology which we have is star topology, which come from its drawbacks. So now let's understand the star topology. In star topology, all the devices are connected with a hub. Okay. So in star topology, all the devices are connected to a single hub through a cable. This hub is central node and all other nodes are connected to a central hub. The hub can be passive in nature, means not an intelligent hub. That means if any data goes to this hub, it will do broadcast. Means it will not filter the data. This is one of the drawbacks. Secondly, many popular protocols are there in star topology, but still it fails to many things. Like cost insulation is high, performance is based on only hub, and the protocols which are happening on this topology is your CSMA, means carrier sense multiple access, and CD collision domain. We will understand them in our protocols, but right now no need to worry. Just understand these are the protocols which occurred in star topology. Then after we come up with with both of these derivative topology called tree topology. In tree topology, we have divided, we have made a topology in such a way that it is a combination of tree and the bus and star topology. So let's understand the tree topology here. So this is the tree topology looks like. So this topology is a variation of star topology. This topology has a hierarchical flow of data. The protocols which were implemented in this topology is DSCP and SSE. And the advantage of this topology is we can add new devices to the existing network. Error detection, error correction looks easy in this topology, but the cost was too high. If new devices is added into the system, it is difficult to configure the hub repository. It is very hard to reconfigure any new devices. So this is the drawbacks. The costs were high. Any new devices connected is become very tough to configure. And if this central hub goes down, if any other hub goes down, the whole network of that hub downwards goes down. So this was the drawbacks of this topology. But still, we come up with again a topology called network ring topology. In that, we have connected devices in a way such that the node is connected with the other device's node, and it can be unidirectional or bidirectional. Let me share that topology image. Just a sec. Yeah. So it forms a ring connected with the devices from two neighbor devices. This node is connected with this node. A number of repeater are used for ring topology with a large number of nodes. If someone sends a data to the node in ring topology with 100 nodes, then data will have to pass the 99 node. Means if this node is going to send data to this node, or let's say there is one more devices here, and it has to go through each and every node. If any devices in between gets failed, the data will be get failed to transfer. And for that, if you do a bidirectional also, like from this side also, then there is again chances to drop the data if that wire goes down. So it was less secure because the data has to travel all the way here to there. But communication was a little fast. So this is the drawbacks of ring topology. Then we come up with mesh topology. Mesh is like where every device is connected with each other. In this topology, communication was faster. But again, the installation and configuration of network was difficult, and the cost to install the wire to every node was so high. So we have not reliably using this topology. Then we did one thing. After learning, after understanding these all topology, every topology have drawbacks. Some are less secure, some have cost efficiency problem, some are lacking with some and some sort of things. Then we come up with again a new topology called hybrid topology. It is a very flexible topology because it use every other type of topology. Let's search for hybrid topology. Okay, let's understand this. If you see here, the topology is very flexible. The size of the network can be easily expanded by adding new devices. Means how? For example, this is a your this thing. So we have port availability here. I can add anything here. If it is, if you can see here, this is your ring, right? Ring topology, and this is your star topology. Means if hub used in this topology are very expensive, then again this is the drawback. But we are not taking in that way. But let's understand the hybrid. Why we use hybrid a lot of time. The topology is very flexible. We can add new connection, new topology anytime by allowing it to a new topology. Very flexible. Then adding new devices in this topology is easy. We no need to disturb the any topology. We can just add our connection and make another topology and share the data to the other topology. So we use this topology over other topology, and lots of the whole internet works on this topology. And this is about this topic. I hope it is clear. Thanks, and meet you in the second video.